Students, we've been learning a lot about exponents lately, and it's all come up to this. There is a function that is exponential. So far, we've learned about linear functions. Oh, sometimes graph a linear equation. Y equals mx plus b. That's a linear function. The x is just a variable and it's multiplying m. In exponential functions, the x variable, the input independent variable, is an exponent. Y equals 2 to the xth power. I didn't know x could be an exponent, but I mean, exponent has an x in it, so it makes sense, right? Exponential growth happens frequently in our lives. Exponential functions also happen frequently. If you think about it, the YouTube sensations, dancing like this and everything, they had YouTube hits that looked like this. Started off with a few amount of hits, and then all of a sudden it went exponential. Exponential functions happen in our lives, so we need to understand how to work them. Let's look at this. Y equals 2 to the xth power. Well, we don't necessarily know what this is going to look like right now, so why don't we create a table of values? X and Y, inputs and outputs. To get a feel for how it would look on the left side of the graph, we'll use some negative numbers. And then on the right side of the graph, we'll use some positive numbers too. So we'll start off at -2. Well, if we input a -2 for x, okay, y equals 2 to the -2nd power. Well, we know that exponents don't like to be negative, so we move this to the denominator. Y equals 1 over 2 squared, y equals 1/4. So when the input is -2, the output is 1/4. What about when the input is -1? Well, again, exponents don't like to be unhappy. So this is just 1 over 2 to the first power, which is 1/2. So when we have an input of -1 as x, our output is 1/2. What about 0? I love these because they're so easy. Anything to the 0th power is 1. Okay? 2 to the 1st power, our next input, well, that's just 2. 2 to the 2nd power, well, that's 4. 2 to the 3rd power, just completing our data table here. 2 to the 3rd power is 2 times 2 times 2, which is 8. And then finally, 2 to the 4th power. Two times 2 times 2 is 8, times 2 is 16. Okay, so we have a pretty complete data table here with 1, 2, 3, 4, 5, 6, 7 values. Let's plot them. So our x values are going to go from -2 all the way to 4. -2, -1, 1, 2, 3, 4. Now our y values go from 1/4 to 16. And we only have 1, 2, 3, 4, 5 spaces on our y-axis. So in order to fit all the way up to 16, we're going to need to go by 4s. 4, 8, 12, 16. So 4, 8, 12, 16. Okay. So when x is -2, y is 1/4, which is almost nothing. When x is -1, y is 1/2, which again is almost nothing. When x is 0, y is 1. We go up a little bit. When x is 1, y is 2. We go up a little bit more. When x is 2, y is 4. When x is 3, y is 8. And when x is 4, y is 16. Big jump. So as we can see, we cannot draw a straight line through this information. A straight line just wouldn't fit here. And the reason is because it's not a linear function. It is an exponential function. So when I draw this line through it, it seems like the next value is going to be really high off the graph. Let's confirm that that's true. Our next x value was going to be 5. So our next x value is going to be 5. What would our next y value be? Well, if we input a 5 for x, 2 times 2 times 2 times 2 was 16 times 2 again is 32. When graphing exponential functions, the input value is an exponent. And what that causes is a graph that either climbs very quickly or falls very quickly. Thank you very much, and have a good day.